This lesson is on complex numbers. Our objective is to simplify complex numbers. Specifically in this lesson, we're going to talk about when you have an imaginary unit in the denominator. So we're going to look for those complex numbers in the denominator. Remember, complex numbers are in the form of a plus bi, where a is the real part, bi is the imaginary part. Now, let's talk about these first couple. This will just help us get the form of what the answers should look like. So when we have this division problem, we're dividing by 3. We've got a complex number on top and dividing by 3. Notice that there's a common factor of 3 in the top. So I'm going to go ahead and factor out the 3. And then I can reduce out, because 3 out of 3 is equal to 1, I can reduce those, and I end up with just 9 minus 4i as my answer. So first of all, if you have a factor top and bottom, you want to factor it out and reduce it. Second of all, if we have a negative in the denominator, that is that leading term, we want to get rid of the negative down here. To do that, I can multiply by negative 1 on top and bottom. And so on the top, I'm going to have negative 13 minus 7i when I distribute through the negative 1. That's going to be over positive 5. Now there's one more step I have to take, because we want these complex numbers divided by a integer. We want to make sure it's in a complex number form. So I'm going to separate out the real part and the imaginary part by splitting up the fraction. So what you're going to list is you're going to have negative 13 over 5 and then minus 7/5 I. Notice I'm going to put the I at the very end. 7/5 represents my coefficient of I. I is my imaginary unit. So you want to make sure you separate them when you have a fraction. Now, just a reminder, in our complex number form, a plus bi, we're going to have times where we have those complex numbers in the denominator. This is where you just have the imaginary part in the denominator. Here you have the binomial a plus bi in the denominator. So when that's the case, we're going to use sometimes just the imaginary unit, and sometimes we're going to use what's called the complex conjugate. Especially on 4 and 5, we're going to use the complex conjugate. Now what that means is if I have a plus bi, the complex conjugate is a minus bi. And vice versa. If I have a minus bi, the conjugate is a plus bi. So that's based on the factoring pattern, m squared minus n squared equals m minus n, m plus n. We're going to take advantage of what happens to the middle terms in this type of problem. So the goal is to get the I out of the denominator using this information. All right, let's look up at this problem. Simplifying this, to get the I out of the denominator, it's a simple process on this one of just multiplying by I over I. Here you're going to have 9i over 11i squared. Just a reminder, I squared, this is an important fact to know, when you square I, you get negative 1. I'm going to take advantage of that and make this 9i over negative 11, because I squared is equal to negative 1. And just to be consistent with what I mentioned over here with the negative in the denominator, let's go ahead and put the negative, you either put it in the top with the 9i, or you're going to put it out in front. So negative 9i over positive 11 for my answer. Now this one, notice it's got a full complex number in the denominator. So I'm going to multiply by the conjugate, double distribute, and it will eliminate the i's in the denominator. You'll see. Let's take a look. So 4 plus 3i, 4 plus 3i is the conjugate of the denominator. If this is a minus, make it a plus. And now I'm going to go ahead and multiply both sides. Now notice I can do this because 4 plus 3i over 4 plus 3i is equal to 1. If you multiply by 1, you end up not changing the value. Multiplying by 1 doesn't change the value, but it's going to change the form to get rid of the I in the denominator. So let's take a look. 6 times 4 is 24. 6 times 3i is equal to 18i over, and in the bottom we're going to double distribute. 4 times 4 is 16. 4 times 3i is going to be 12i. Negative 3i times 4 is negative 12i. Look what's going to happen there. And then negative 3i times positive 3i is negative 9i squared. Now take a look here. In the top, we're going to have 24 plus 18i. And so it's a complex number, which is okay. Numerator, it's fine. But down here, these two terms are like terms, and they're going to get rid of each other because they're opposites. So I'm going to have 16, and then negative 9 times negative 1, because I squared equals negative 1, is going to be plus 9. So you get 24 plus 18i all over, in this case, 25. Look for common factors that you can take out and reduce like we did over here. I don't see any. And so we're now going to just split it. So it's 24 over 25 plus 18 over 25i for my final answer. And I'll circle this one too. Now, this one, another complex number in the denominator. We also have one in the numerator. You might be thinking, okay, complex conjugate. I've got the complex number in the denominator. Which one do I do the complex conjugate of, the top or the bottom? You're always going to do it with the bottom complex number because our goal is to get the I out of the denominator. You don't have to worry about the numerator, it can still be there. So when I multiply by this, I'm going to do the conjugate of the denominator, 5 minus 2i, and make sure you multiply by top and bottom. If I did the conjugate of this top one here and the bottom one there, that wouldn't be equal to 1, it would change the value. So that's why you have to make sure you pick the denominator, the complex conjugate for that, and do it in the top and the bottom. Let's multiply it through, double distribute in the top. 3 times 5 is 15. 3 times negative 2i is negative 6i. 2i times 5 is positive 10i. And then 2i times negative 2i is equal to negative 4i squared. In the bottom, I'm going to go ahead and double distribute on this one. So I'm going to get 5 times 5 is 25. 5 times negative 2i is negative 10i. 2i times 5 is positive 10i. And then 2i times negative 2i is negative 4i squared. Now, remember, this is another point I want to get, is people look at this. They might even look at this and say, well, can I just reduce out the 10i and the negative 4i squared? You can't. When you reduce a fraction is when you have something over itself as a factor. Only a factor over a factor reduces, like this one. 3 over 3 is a factor. It's 3 times a parentheses, and a 3 in the denominator is a factor. That you can reduce out. But these are being added and subtracted. You can't reduce out things that are being added or subtracted. They're not factors. So don't make that mistake of simplifying those and reducing them. Now let's simplify the top. We're going to have 15 minus 6i plus 10i is going to be plus 4i. And then minus 4 times negative 1 is going to be plus 4. All over, down here we're going to have 25, and here is the whole reason why we did the conjugate. Those two terms are opposites. They can cancel each other out, so you don't have anything in the middle. Then negative 4 times negative 1 is plus 4. So on the top, I'm going to have 15 plus 4 is 19, plus 4i. The bottom, I'm going to have 29. Look for a common factor, top and bottom. See if there is something you can factor out and reduce. There isn't, but do separate them. So 19 over 29 plus 4 over 29i. So when reducing complex numbers, if you have an I in the denominator, the key is if it's I all by itself, multiply by I over I, and then reduce, simplify and reduce. If it's a full complex number with both the real part and imaginary part, multiply by the complex conjugate, and then simplify those, remembering to separate out the real part and the imaginary part at the end, and you'll get the division of complex numbers.